Hello. Is square root x inverse of x square? This is a huge question, asked so many times in so many different ways. And most of the time, students get wrong answer. We'll try to see why they get wrong answer. It looks like, yes, they are inverse function, right? If I do square of this, I get x, right? And if I do square root of that, I get x. So inverse and the function, if you combine them together, you should get x. So it seems that it will be, but actually it is not. And let's see how. Let's name these functions, okay? For the time being, let's say gx is equals to square root x. And let fx equals to x squared. Now, if I do g of fx, then what do I get? So normally when you do g of fx, that means g of, what is x, fx? X square, right? And g of x square means gx is this. So, first understand, g of fx means what was fx? Fx was x square. So I wrote that here. Do you see that? Try to understand that part. It's kind of tricky. Now, so I got g of x square. Now g of x square, but gx is defined as gx square equals to square root of x. So we'll plug this value here, okay? So when we plug this value here, we get this is equal to square root of x square. So this is this. Now we know if g of fx is equal to x, then they are inverse of each other. Otherwise, they're not inverse of each other. Now, is this equal to x? That's a big question mark. Well, the answer is no. The answer is no. Most think yes. So that's a huge problem. Now, how to explain you? I do have a video on this. Is square root of a square equals to a? The answer is no, is absolute value of a, correct? Now, I've explained it like this over there. Let me tell you in short here. Let's say x equals to 7, then 7 square is 49, and square root of 49 is 7. So we get the 7 back, correct? But if x equals to minus 7, now square of minus 7 is 49, and when you do square root of 49, you get 7. But 7 and minus 7 are not same. You always get a positive value. Do you understand? That's the difficulty. But you should have got minus 7, which you don't get. So that's why square root will not give you x. Now here, I like to explain you in a very different way. The thing is that when you are given gx equals to, let's go fresh now, gx equals to square root x, then first thing you should note is, what is the domain and range of this function? Now, domain of this function is x belongs to real numbers where x is greater than or equal to 0, correct? And what is the range of this function? Range of this function is y belongs to real number and y is greater than or equal to 0, correct? Do you agree with me? Have a close look at it. Here is the graph of the function, square root x. Is it okay? It is not valid for quadrant 2 or negative values of x. Only positive values, right? Non-negative real values are in the domain of gx. Now, if it has an inverse function, then what will happen to inverse function? Domain and range will flip for inverse function. Is it okay? What I'm trying to say is g of inverse x will have a flip domain and range. So we are expecting a domain of x belongs to real numbers where x is greater than or equal to 0, and range y belongs to real number where y is greater than or equal to 0. Well, looks similar kind of, okay. But if you try to analyze your function fx equals to x square, then what is the domain and range of x square? Now, let's draw it. X square is, okay, I just drew that line, so let me not do it like this, okay. Let's say this origin, okay. Let's say this is not this one. This is my x square. Now here, the domain is x belongs to real number. But what domain are we expecting? Greater than or equal to 0. That is what we are expecting. And here, the domain is x belongs to real number, right? And that creates the problem. As far as the range is concerned, range is okay. Range is y belongs to real number and y is greater than or equal to 0. So that part seems to qualify for our inverse function. Do you understand? Now, that means we have seen that there is no compatibility of what we are expecting and what we have. So there's another thought of mine, that is to say, when you are given the function gx equals to square root of x, then what should you say? You should say here x belongs to real numbers where x is greater than or equal to 0. So that means for a restricted domain, so we have restricted the domain, do you see that? So for restricted domain, this is the restricted domain, x is greater than or equal to 0. If we work out the inverse of this function, then x squared becomes the inverse of this function. Do you see that? Only for the restricted domain. So, and I'll draw a graph again for you to show you. I'm not doing many calculations here, but basically trying to get the concept through. This is my function square root x, correct? Now, square root x has values like, let's say 0, 0, and let's say this is my point 1, 1. And let's say we have 2, 4 somewhere, right? So this is 1 and then this is 2, and let's say this point is 2, 4, correct? Now the inverse of this function should have flipped values, right? 1, 1 is okay. If I draw a line y equals to x, this will go through 0, 0 because x equals to y equals to x, kind of, right? Okay. So let me draw a line here. This line is y equals to x, right? So our inverse of this function will be such that this point should be 4 and 2. So this is 2, this is 1, 2, 3, 4. So at 4 we have 2. It doesn't look like that, but anyway, this point will be 4 and 2. And then when it gets reflected, then at 2 we should get 4. It's kind of messy, but okay. What I'm trying to say is like this. So these points get reflected there, and then we have a function here which is actually a part of x squared. So if we restrict the domain to x greater than or equal to 0, in that case, yes, square root x and x squared are inverse of each other. But if we don't restrict, then they are not. So whenever you get this kind of a question, then the answer is plain and simple forward. If the domain is restricted that is x belongs to real numbers where x is greater than or equal to 0, then fx equals to x square and gx equals to square root x are inverse of each other. Otherwise not. Okay? Thank you.